Hi, and welcome to the fourth objective, where we're going to talk about a typical firm's costs curves and kind of finish up a little bit of our discussion on costs. And we're also going to look at a little bit of economies of scale as well. So without further ado, let's go ahead and get to it. Share my screen with you. Okay. So in this particular chapter, what we're looking at are fixed and variable costs. So this just kind of goes over again what we talked about in the previous objective, and looking at fixed costs again. We said Farmer Jack was his land. Some other examples: cost of equipment, loan payments, rent. Some variable costs: the wages he pays his workers. Remembering that total cost is equal to fixed cost plus variable cost. Here's a second example, and this is much more general and it applies to various types of firms. So here we go, and so we have our fixed costs, and remember our fixed costs in this example are going to be $100, okay? And again, notice that they are remaining fixed regardless of the number that we produce. So if we look at this, fixed costs don't change. Again, if you ever want to find fixed costs, take a look at what that quantity is, what the total cost will be at a quantity of 0. That's going to be your fixed cost. Here are our variable costs. So I went ahead with the blue line, and notice the fixed costs remain constant in the short term regardless of the quantity that we produce. Here's our variable costs. Notice that our variable costs increase proportionately as output increases. If we add the two together, because remember that total cost is just our fixed cost plus our variable cost, and that's why you can find fixed cost at a quantity of 0 by looking at total cost, because our variable cost there would be 0. So we have our total cost curve, and we're going to go ahead and put that on. Again, notice that this green line, our total cost curve, represents the fixed cost of the blue line, this line right here, fixed cost, oops, fixed. Let's see if I can save that. Oh, let me erase that. How about that? So much fun. Okay, there we go. All right, let's try taking that again, using the pen. Okay, notice that that is our, anytime I leave this, okay, there we go, is our fixed cost. Here's our variable cost. Adding those two together then make this green line, which become our total cost. Okay? Now, it's interesting in the behavior of these curves. Notice that the variable cost seems to be pulling up the fixed cost curve. We're going to talk about that in just a moment. If we look at our marginal cost, and remember that marginal cost is just, there we go, marginal cost is just the change in total cost divided by the change in quantity. So as we move, where did the 70 come from? We take the 170 minus the 100, that's our change in total cost of 70, divided by 1 minus 0 is 1. So that's what gave us the 70 there. And that's true for all of these other marginal costs as well. Remember that marginal cost is also the slope of the total cost curve. Okay. And when we look at this, marginal cost rises as quantity rises. Now, why would that be so? And it's because if we look at this, variable cost pulls up the total cost curve. And that's why this marginal cost rises as quantity rises. Okay, so let's take a look at this example. Let me erase the ink that's on here. Okay, so one of the questions we have is, why is marginal cost kind of this Nike swoosh, if you want to liken it to that? And when we look at the area from here to here, this line's this area of the marginal cost curve, what we're essentially saying here is that our total costs are being pulled down because we're spreading our quantity, our fixed costs, over a greater quantity. So fixed cost is being spread over more quantity. And so that's why this decreases so greatly. It then bottoms out. And then notice that this area here, then we have variable costs start to really increase in this general area. And what we would do is look at this and kind of say, okay, at 2.5 units, and most economists will round this up to 3 units and say, okay, at 3 units and above, we really have variable costs are what really are increasing our overall total cost. Here, we talked a little bit about it in the last objective, but we have it clearly defined here. Average fixed cost is just the fixed cost divided by the quantity. This is where economists and accountants really differ, because an accountant would say you can't do this. Fixed costs are what they are. But in economics, we like to look at the behavior of the fixed costs as the quantity increases. So here, we're going to go ahead and take a look at this and notice that fixed cost declines as the output increases. And that makes sense because we're spreading those fixed costs over more and more units. So here's an example of our average fixed cost. Notice again, up here it's pretty high because we're only producing 1 unit. So if we follow this down and we look at this, we're only producing 1 unit. And so that 1 unit is trying to cover all the fixed costs for our business. As our quantity increases, then those fixed costs can be divided by more and more quantity. So our average fixed cost curve here declines because the fixed costs are being spread over a greater quantity. And again, that's something that accountants do, but economists want to get a generalized idea about how that's behaving. Average variable cost, remember, just average is anything divided by the quantity. So we're going to say average variable cost is equal to our variable cost divided by our quantity. Now, we're going to see that, notice average variable cost increases and as our quantity increases. We also like to take a look at the patterns here. So notice it starts at 70. It bottoms out right here at 52.50, and then it starts to increase after that. So let's take a look at this particular curve. And notice again that the average variable cost curve starts off here, and here's where it bottoms out at that 52.50, right around 4 units. This is our lowest average variable cost. Let's put them together then. So we have total cost, we have average total cost, which is just total cost divided by quantity. What is making that curve look the way that it looks is because we also can get to average total cost by adding together our average fixed cost and average variable cost. So average total cost can be total cost divided by quantity, or if we take the average fixed cost and add that together, we're going to get our average total cost. So hopefully you can see that pretty easily here. Now, just looking at our average total cost and our average fixed cost, it's U-shaped. So let's take a look at why that would be. Again, remember that what's really behaving, or what's the origin of this, is that in this section right here, average fixed cost is being spread over more and more units, because remember, average fixed cost is just fixed cost divided by quantity. Then it bottoms out right about here, 4 units-ish. And then in this particular area, then we have average variable cost, and variable cost increases as quantity increases. Now, we are used to looking at one supply curve, and instead of just one supply curve now, we have 4 basic curves that we want to look at. Again, we have the marginal cost curve, we have the average fixed cost, average variable cost, and average total cost. So the legend here shows you how each cost looks. Now, when we talk about efficiency and efficient scale, the quantity of output that minimizes the average total cost. So let's look at that. If we look at average total cost here, we can see that the quantity, where is it the smallest? Well, it's kind of hard to see on this particular chart, but right about there is where this average total cost is the smallest. Okay, let me just back up a minute because I want to show you something else. Okay, so looking at our average total cost, it's kind of easy to see right here that our average total cost is the smallest at 5 units. So if I go back to my original, where I was trying to find that, it's right around 5 units. Okay, so we're going to go ahead and take that. I'm going to erase that. Okay, go ahead and add it back. Now that we know exactly where it's at, using the graphs together with the charts, then we can see that right here at 5 units is where the average total cost. So this would be our efficient scale. Okay, now again, just to kind of show you where we're going with this, let me go ahead and put in a revenue curve. Okay, and I'll just go ahead and use that. Okay, let me go ahead and put in a revenue curve. I'm going to put in a revenue curve right here at $100. So this will be the price. And for some markets, price is equal to marginal revenue, which is equal to average revenue, all at the price. Okay, so I just want to show you where we're going with this so get you a kind of get you an idea. If this is the marginal cost curve, which it is, where marginal cost and marginal revenue meet, that's going to be where our profit is highest. So in this particular example, because at this 5.5 units, right here where these two crisscross, this is where marginal revenue equals marginal cost. I would then follow this down and ask, is this firm profitable? Well, I would look at, sure it is, because if I say that that line, where marginal revenue, marginal cost, where that hits the average total cost curve, the green line, then everything that is above that must be the profitability. So, in this instance, all of this becomes profitability. Okay, so this is an example of some of the things that you'll be asked to be doing, particularly in Applia. Oh my, how did I do that? Okay, there we go. Wasn't sure how I did that, okay. Again, this whole learning curve that we're working with. Okay, so variable cost, remember those are those costs that increase proportionately as quantity increases. And we don't have a fixed cost column here, but I'm going to go ahead and add one. And remember, fixed cost plus variable cost equals total cost. Average fixed cost is just fixed cost divided by the quantity. Average variable cost is just variable cost divided by the quantity. If we add average fixed cost and average variable cost, we'll get average total cost, which is just total cost divided by quantity. The last portion is marginal cost, which is just the change in total cost divided by the change in quantity. Now, notice again, we don't have a fixed cost, but I can look right here where my quantity is 0. And if my total costs are 50, that must mean that fixed costs here are always going to be 50. And we know that's true of every single unit. There's our double check. Notice the difference of 50. Notice the difference of 50. Okay, variable costs at a quantity of 0 are always 0. Okay, now I want to get total costs, so I do 10 plus 50, which would be 60, right? Average fixed cost divided by quantity, so 50 divided by 1 is equal to 50. Average variable cost is just going to be my variable cost divided by quantity, or 10 divided by 1. Average total cost is going to be the total cost divided by quantity. Okay. I can go ahead to quantity 2 now, and I can say, okay, 30 plus 50 must be 80. That's true. My fixed cost, 50 divided by 2, so that's going to be 25. Average variable cost, 30 divided by 2, quantity, so that's going to be 15. And average total cost, 15 and 25, which is going to be 40. Now that I know what the average total cost is, I can get the marginal cost. And I can say 60 minus 40 is equal to 20. We went from 2 units to 1 unit. That equals 1. 20 divided by 1 is equal to 20. Notice there's a pattern forming here, and that's intentional. Excuse me. Okay. We don't know variable cost here. We know fixed cost is 50. Total cost, we don't know. But we do know average total cost is 36.67. So I'm going to take this 36.67, I'm going to go up here, and I'm going to say, okay, 36.67 is equal to my change in, I'm sorry, that's incorrect, is equal to, here we go, is equal to my total cost divided by quantity. Now, I know that my quantity here is 3. So I can just go 36.67 equals total cost over 3. I can then cross multiply and say total cost is equal to, I brought my calculator, so I'm going to just go ahead and plug that in. How about 110? So now I know that my total cost is 110. 110 minus 50 is going to be 60. And now I have this area filled out as well. Marginal cost, just my change in total cost divided by my change in quantity. So here I have 150 minus 110, which equals 40, over 4 minus 3, which equals 1. So this is going to be 40. Again, see the pattern starting to emerge. I would double check at this point and say, okay, I've got average variable cost. That's just 37.50 minus 12.50, which is in fact 40. I'm sorry, no, that's wrong. Is in fact 25. Okay. Again, what's my total cost here? 150 and 50, so 200. Average fixed cost is going to be my fixed cost divided by my quantity. So that's going to give me 10. Over here, average total cost, I could just add those together. That seems like the easiest way to do it. And then I dare say this is going to end up being 50, but let's double check. So I take my total cost, 200, minus my previous total cost, which equals 50, over, and I have 5 minus 4, which equals 1. 50 over 1 is 50. And that's how we would fill out a chart like this. Let's just make sure we were right. And look at that, we were. Okay, now why is the average total cost curve U-shaped? And I've gotten into this a few times, but I do want to make sure that I really do a good job at this. So as quantity increases, what happens is over this line segment that you see in red, average fixed cost, because it's being spread among more units, is pulling down the average total cost curve. So average fixed cost is the dominant kind of reason why the average total cost curve falls initially and falls quite steeply over the first couple units. Then eventually average variable costs will start to rise because remember, variable costs increase as the quantity increases. So here what we have is the port that's taking over. Initially, we didn't have a lot of variable cost, and so spreading the fixed costs among more units is what's allowing the curve to decrease significantly. And then over here, average variable cost, as the quantity is increasing, that's pulling up average variable cost, which is likewise pulling up the average total cost curve. And again, that efficiency of scale, or that efficient scale, is the quantity that minimizes. So here, and again, sometimes a little difficult to see in a chart, but in a graph, but you could see it in a chart pretty easily. This is where our average total cost is minimized. So if that is a profitability, that's where we would be. Okay, here we have marginal cost. And again, sometimes don't get lost in all the terminology. Just remember that marginal cost is equal to the change in total cost over the change in quantity. Average total cost is average fixed cost plus average variable cost. So now we see another point which is probably important to take note of, and that's this idea right here. So at any quantity which is less than where average total cost equals marginal cost, at any quantity that's less than that, average total cost is falling. And that's important for us because the point here, all points prior to that, our average total cost is falling. And that's important because past that point, when we get over into 4.75 maybe and above, then average total cost is rising. Now that's not good for us, right? We want average total cost to fall, not to rise. So in looking at this, right at the point where average total cost equals marginal cost, that's where we have our lowest average total cost. Now, we've been talking about the short run. And in the short run, we have what we have, right? Everything is fixed. And most of the inputs are fixed cost. But in the long run, and this is important to note, all inputs are variable because we hit capacity. Okay, so how do we know when it's time to change factory size and some of those things? So average total cost at any quantity, okay, And what we want to do is to use the example that we have here and to put it into different scenarios for us. So the first one, actually different scenarios for us. So what we're going to do next time is we're going to take this point right here and we're going to say that at anything less than that point, that's efficient. And we're going to make decisions based upon what type of factory and when to change, because there is actually a right time to change factories. Okay. And there we are. So we are now finished with this particular objective. Jump back over here. For some reason, it's not letting me end the show there. So I'm going to pop back over here. Okay. So thank you for your time, attention, and we'll look forward to seeing you on the next objective. Thanks.